Hello everyone, welcome to this video. In this video we have to show that the group U20 that is not generated by any element k in U20, right? Hence this group U20 that is not cyclic, correct? This is what we have to show here. So you know in U20 this is a multiplicative group under multiplication modulo 20 which contains all the elements less than 20 which are relatively prime to 20, right? So you have the elements as 1, 3, 7, 9, 11, 13, 17 and 19. These are the only elements which are less than 20 and co-prime to 20. 1 here acts as the identity element, right? Once you know this thing, now we'll be checking this for each of these 8 elements present over here. So we'll be checking what is the subgroup which is generated by this K, where K is some member of U20. For that, we first of all consider the subgroup which is generated by A1, right? So you see identity generates only the identity element. So you have this as a singleton set which consists of identity element, which is the trivial subgroup of this U20, right? And so therefore it is not equal to U20. You can clearly see in this case. What about this? The element 3. So let's see the subgroup which is generated by 3. It contains 4 elements 1, 3, 7 and 9 within it. How? If you take 3 raised to power 0 it is 1. If you take 3 raised to power 1 it is 3. When you take 3 raised to power 2 it is 9. When you take 3 raised to power 3 it is 27. Now 27 is not an element of this group. So therefore we have to calculate 27 mod 20. So when you calculate 27 mod 20 you have 7 as the remainder in this case. Correct? If you calculate 3 raised to power 4 it comes out to be 81. And 81 is also not present here. So when you divide 81 with 20, right? So you have 1 as the remainder. So you see the numbers start repeating. 1 was already present here. So thereafter if you calculate 3 raised to power 5 it would be equal to 3 under mod 20 and so on, right? So the sequence would continue, repeat itself. 1, 3, 9, 7, then 7, 2, then 1, 3, 9, 7 and so on, right? So the subgroup which is generated by 3 contains only 4 elements, so this is not equal to U20. Let's see another one, the subgroup which is generated by 7. So the subgroup which is generated by 7 also contains the 7 elements. You can see here 7 raised to power 0 is 1, 7 raised to power 1 is 7, raised to power 2 is 49, which is 9, raised to power 3 is 3, raised to power 4 is again 1. So you see after this we have elements which are repeating, so therefore no need to calculate furthermore. What about the subgroup which is generated by 9? It contains only 2 elements, the identity element and itself, correct? What about the subgroup which is generated by 11? Again the same thing, the identity element and the member itself, which is 11, correct? All of them, they are not equal to U20, you can clearly see. What about 13? 13 also contain only 4 elements which are 1, 9, 13 and 7. How? If you take 13 raised to power 0 it is 1, 13 raised to power 1 is 13, 13 raised to power 2 is 169, and when you take its mod 20 it comes out to be 9. 13 raised to power 3 is 2197. When you take its mod 20, the answer comes out to be 17. Right? 13 raised to power 4 again give you 1. So you see, you have the numbers repeating. So you stop here. So therefore, you have 4 elements present within this subgroup which is generated by 3. Correct? What about 17? The subgroup which is generated by 17 also contain these 4 elements. Hence, both of them, they are also not equal to U20. So therefore, you see all the elements, one is left. We have the subgroup which is generated by 19. It only contains 2 elements within it. Hence, it is also not equal to U20. So you see, U20 is not equal to any of the K for any K in U20. Hence, this is not a cyclic group. And this is what we wanted to prove here in this particular question. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.